Hello everyone, welcome back to the channel. This is Akshat Mishra and today I'm upsolving this problem number C, which came in CodeForces round 847, which was for division 3. It's called Premutation problem. So we are giving a sequence of n numbers and it is called a permutation if it contains all integers from 1 to n exactly once. So I guess you know about what is a permutation. If you don't, I will just tell you in the whiteboard. So suppose you are given a number n, which is, let's say, equal to 6. Then a permutation is a sequence which contains all numbers from 1 to 6. So let's say 1, 4, 5, and 3, 2, 3, 4, 5, 6. So let's say n was 7. So yeah, this is a permutation. The numbers can be in any order, they don't need to be actually sorted. So I hope you understood what permutation means now. So now we are given that Christina had a permutation P of n elements. She wrote it on the whiteboard n times in such a way that while writing the permutation at the ith time, she skipped the element Pi. Suppose Christina was writing the permutation, let's say the first time, then she would skip the number 1 and the permutation would become 4, 5, 3, 2, 6, and 7. And similarly, when Christina would be writing it the permutation the second time, she would skip the number 4. So except 4, all numbers would be there: 1, 5, 3, 2, 6, 7. And if she would be writing it the third time, she would skip the number 5. Similarly, in fourth time she would skip 3, and thus she would be writing, I guess, 7 permutations in total, out of which each number would be skipped once. Okay, so yeah, here it is given. If she wrote 4, 2, 1, 3 as a permutation, then she would be skipping each number once. So 4 would be skipped for the first time. In the second permutation she would be missing 2. In the third one she would be missing 1, and in the fourth one she would be missing 3. Now what Christina has done is she has written these permutations in an arbitrary order. So thus, to make the question a little bit tricky, she has written it in some arbitrary order. So our task is to find the original permutation. Like here it was 4, 2, 1, 3. So that we need to find. So to take the input elements, it is quite clear from the question that we would be creating an array, a 2-dimensional array with the n number of rows. N is equal to the size of the permutation and n minus 1 number of columns. Okay, so in the first row, in the first column, the count of the number which is maximum would be equal to the first element, and the count which be the number which would have less count would be the second element of that permutation. Like you see here, it is given 4, then in the second row it is given 4, in the third row it is given 2, in the fourth row it is given 4. So the count of 4 is greater than 2, so 4 would be the first element of the array and 2 would be the second element of the array. And a simple approach would be now to just make 4 as the first element of the array and 2 as the second element of the array, and iterate from the second column for each row. Yeah, for each row now a simple approach would be to iterate from the second column till the end column, and we would maintain a vector where we'll be pushing back elements which would be having first more count in that particular index and second less count in that particular index. So what I was trying to say is that in the first column we would first maintain two elements. One would be the one with more frequency, and the second would be the number which would be of less frequency. So the number which would be of more frequency would be pushed back to our vector v, and the number which would be of less frequency, which is here it is 2, would be pushed back after that number. So here the count of 4 is greater than 2, so first 4 would be pushed back to our, so count of 4 is greater than 2, so first 4 would be pushed back to our vector and then 2 would be pushed back to our vector. And after this what we will do is iterate from the second column for each row and check whether in that column the element, if it is equal to our element at that index of the vector. So let's suppose in the second column our number is 2 and in the second element of the vector the number is 2. Okay, if both these numbers are same then we'd continue, otherwise if the number is different then we'll push it back to our vector. So here the number is different, which is 1, so it would be pushed back to our vector. Okay, and after this we'll stop the loop and iterate to the next element. So I mean iterate to the next column, and if in that column our number is again different from the present index of the vector, then we'll again push it back. So in the first iteration it was 1, so it is same, so it will be not pushed back. Now the number is encountered, which is 3, so it will be pushed back to our vector, and thus after this approach we obtained the original permutation. Okay, so now let's check the code of this problem. So yeah, here is the code of my problem. We have t test cases and we have maintained an array of number of rows equal to n and number of column equal to n minus 1. We take the input. Now we maintain a vector where our final answer would be stored, and for checking the element number, now for checking the number at the first column which is of greater frequency, we have maintained two element variables. First stores the value at the position number 0 0 of the array, and the second element would contain the element which is different from this. Count 1 maintains the count of this element and count 2 maintains the count of this element. Okay, and now we will traverse through the array, and if we found that count 1 is greater than equal to count 2, then in the vector element 1 will be pushed back first, and thus it would become the first element of the permutation, and element 2 would be pushed back second, and thus it would become the second element of the permutation. And otherwise if count 1 is less than count 2, then element 2 would be pushed back first and element 1 will be pushed back first. Okay, so Now, as I said, we'll make a nested for loop, and we'll ARR at j and I indicates that we are traversing through the rows, not through the columns. Okay, so it checks for a particular column at each row whether the element is same as the present index of the permutation or different. If it is different, then the element would be pushed back. And j equal to n indicates that we are coming out of this loop, so to check for the next column. Okay, so I hope you understood the problem, and I'll add the GitHub link to the code in the description, and if you have any suggestions for the channel, please comment it down, and do like, share and subscribe the video. Thanks for watching.